Hello, and welcome to Data Link, the Data Window and DataStore missing ancestor link presentation. I'm your presenter, Mike Sear, and welcome to Elevate 2020. So for our session agenda, we're going to be talking about the problem, what we're trying to solve here with this common ancestor object. We're going to talk about the options to solve the problem, side-by-side comparisons of the pros and cons of those options. And then ultimately the data link option, which is the NVO common ancestor object that we'll end up going into detail on. And what works about it, the good, what really doesn't work that well, the bad aspect of it, and some of the workarounds to get the object to work the way that we need it to, and how that actually ends up working a lot better than the other options that I've tried in the past and simply haven't sort of worked well enough for me. And then we'll have a conclusion. Really won't have any questions because we don't have any way to give proper feedback, but you could probably send questions into Elevate and Appeon and filter through that or through the news groups as well. So let's talk about the problem. What is it we're trying to solve here? What we end up doing is we end up trying to encapsulate a lot of business logic, usually in NVO, and that object's usually we're working on data window initially because our application tends to be very visual and all the data is sort of presented within the data window. But then we have some standard functionality we want to do in an NVO. And then we send that data window as a parameter to the NVO so that it can process that logic. Usually have a lot of get items, set items, a lot of other functions as well that are standard for using the data store. Again, the parameter to the NVO will be the data window. Then at some point you realize we need to have it work more than just a data window. We need to work on the data store, occasionally on a DataWindowChild, but to be honest, it's not really very often. But it's almost always the data store as well. The reason why is we're creating maybe a batch process. We don't want a visual component to it at all. Or maybe it's a situation where it's going to be some sort of an API, and again, we don't want a visual component to it. So let's give an example here. We have a NVO that basically what it does is it'll set the a column value to the name of the person who last changed the data or who created the data. So on a per row basis, it'll basically have some tracking information if you changed or created the data. So this is an object that created, I just call it modified user setting. And it has some standard functions here. So in this particular case, we've already extended it out to work with both the data window and the data store. So typically, in order to solve the problem, the first situation, the first case of an option for handling that is using an if-then statement. In those situations, you need to register probably both a data window and a data store object. In this case, we're registering multiple. That's why it's an array. We're also tracking whether or not it's a data store or not. That's why we have this Boolean. We're also then tracking the column names that we're going to be setting the values, basically the username on for basically either create or a new row versus a modified row. So let's take a look at the register function first. Here we're registering a data window, and we're putting it into the an array. We're then setting the user and basically the column names for the who's storing the username on both the created and modified columns. So this way we're tracking what columns need to have those values set on it on this particular data window. We're also just setting the fact that in this particular case it is not a data store. That's why the data store Boolean value is set to false. And we're also tracking some other things to make sure that the modified ID is being set. So that's pretty standard stuff. What the function really does, or the meat of it is, we have a pre-update function so that when a data window is being updated, it'll call this first. it runs down through and says, hey, give me any modified or new rows. And as it finds them, it'll then set the value. So in this particular case, it is saying, hey, give me my next modified, depending on whether or not it is a data store or not. It's going to then call the correctly casted uh, array value. In this case, it's a data window, and it's going to call it get next modified. And you can see it uses an if-then statement to do that. And while the row is greater than 0, it goes through this loop and sets all the rows to either a new or updated value, modified or create, depending on what happens. So if it's a new modified, it will do it'll set the created user value. If it's modified, it will set the modified user column to the username. So notice here, we're using a lot of if-then statements. So as you can see, it's not a big function, but it's not particularly readable because you have all these if-then statements that are really calling the same exact functions, just the ones on a data window versus a data store. So that's really the crux of the problem. So let's talk about how data stores and data windows really relate to each other. Switch over here. So let's look at it from the browser perspective. So open up the browser in Power Builder, went to the system objects and basically did a show hierarchy here. So we can see that the power object is, of course, the ancestor object to every object in the system. And we can expand it out to kind of find where data windows, data stores, and DataWindowChilds actually relate to each other as well as the power object. So let's start with the DataWindowChild. If you go to the structure, you can see that it's actually DataWindowChild is a type of structure, which is a type of power object. The data window, or I'm sorry, the data store is a non-visual object. So that's its immediate ancestor, and then its type ancestor is power object. And data window is the whole way down under graphic object, window object, drag object, and then you get to the data window. So you can see there's no direct ancestry between them. The only common ancestor, of course, is the power object. So again, to reiterate, this is a hierarchy between the power object, the data store, data window, and DataWindowChild. So it's not even, it's very indirectly related. So let's talk about the power object itself. A couple things. There are no events. There's one property, and there's 6 functions. So there are some, these can be of some use in your processing, particularly the posting and triggering of events, in order to find out kind of what they are as well as the type of. But really, it's not of much use for what we're trying to do here. So again, the problem is we have no useful ancestor object to use. Some of the options for getting around that is using things like the dynamic keyword, if then else, which was in my example. You can also use function overloading, and you can also use shared data. And I'll go over how all of those work. But ultimately, they all have their own drawbacks. And ultimately, none of them really solve the problem of having a relatively easy to use object that works truly like a common ancestor object. I mean, really comes down to there just has to be a better way for all this stuff to work. So a couple of our goals is obviously we want to work with Power Builder, but we also want to work with Power Server. And I'm talking with Power Server 2020 and below. With Power Server 2021, a lot of the pieces that don't necessarily work same way in Power Builder should in theory be gone. So some of these issues may not be relevant in the future. Has to support not only data window and data store. Also want to work with DataWindowChild because why not? Might as well get that all working. We also want it to be very easy to use, which really means that the function names should all be identical wherever possible, so that we're not trying to relearn or come up with a whole new set of function names. It should also be very easy to refactor existing code, and the object itself should be fast. So those are our major goals here. So to reiterate, here are our options. So the if-then case statements, dynamic, using the dynamic keyword, function overloading, utilizing share data, that's an option as well, and then building your own common ancestor, which uses actually a few of these options sort of together to make it all work kind of very nicely. So regardless of which of those options you use, when you're setting up an object that is designed to run business logic on either DataWindow, DataStore, DataWindowChild interoperatively, you typically will have a similar set of setup options. So, one of the options you'll typically have is a power object, possibly, and that's to store the what you're running here. So if it's a data window, the power object will simply point to that. If it's a data store, the power object will point to that. And then you'll have the main function where the real work is really being maintained. So that's where the real work is being done. In this case, it's called a function PO, and it would basically takes the power object IPO and run all the functions on that. So if you're using typically any of the first several of those options, this is kind of how you're setting it up. And if you're using the common ancestor object that we're building, you'll use something kind of similar to this. Same general idea, where you're using function overloading to send in your data windows and data stores and DataWindowChilds, and then have a standard function to process everything else, to do all your real work, essentially. So option number one, if-then statement, or the case statement. So major benefits here are that it's very fast, it's conceptually easy, it's a simple statement, if then else. It also works with properties. So if you're using data window like data object and other properties from the data window or data store, that works fine. So the drawbacks is that you're gonna have if-then statements everywhere. So if you remember my example, that had a lot of different if-then statements, made it confusing to read. The other way of doing it, of course, would be big code blocks. An if, then all your code, else, same code except maybe for a data store instead of a data window. So it's a one big if. So it's not particularly readable at all either. Makes it very hard to maintain. Relatively difficult to test, but very hard to maintain. So here's an example of how that would work. We'd have our function and basically do a type of. I typically, when I do this, is I use a local Boolean variable to identify whether or not it's a data window or data store. Notice in that case, it doesn't really work with a DataWindowChild. And then I just have if-then statements. If it's a data window, then use the data window casted object. Otherwise, use the data store. Use your get items, set items, what have you. Like I said, the other option of doing this is to do one big if statement. So instead of a lot of these little if-then statements, you could have one big if statement. So it'd be if data window, then get item, set item, sort, retrieve, update, what have you, and then the same exact data down here, same exact code down here for the data store. And if that's your situation, or that's the way you prefer to code it, then your other option would be to use an overloaded function, which is our third option. Second option is using a dynamic keyword. So in that situation, you simply use your power object and call your functions with a dynamic keyword. the major issue there really is that it's only evaluated at runtime. So that means if you do have a typo, you will not find it until runtime. So it's relatively difficult to code that in correctly. The dynamic keyword is also roughly 25 times slower than if-then case blocks. May not be an issue if you're mostly dealing with data windows. Users won't typically notice that, but if you're doing a huge volume of processing in a batch mode, then this could potentially be something that slows it down enough to make it an issue. Third option is function overloading. The idea there is you're going to write a same exact code multiple times, one for data window, one for data store, possibly one for DataWindowChild if you're going to use that. In that scenario, what you typically would do is create maybe a data window one first, get it working, and then copy all that code to an overloaded function for the data store. And anytime you make a change to the main one first, and then copy it over to the secondary ones. So it's a lot of copy and paste, which is pretty quick and easy. However, it is easy to forget to copy those changes over. And anytime you have multiple copies, you run the risk of having a mistake where one isn't exactly the same as the other. The last major option, that's relatively standard option, I think, is using shared data. The idea there is you're going to create a data store using the exact same syntax as your source data window. Now, if you're calling this function, your function with the share data, and the source object is really data store, not a data window, then you're not creating the secondary data store doing the share data. You're just operating on it directly. But if it's a data window, what you would do is you create the secondary copy in your data store, do all your operations on the data store, and because you're using share data, it actually affects the main data window. So it works really great in a lot of situations. However, some functions do not work on shared. The error information is actually only available in the main object. So that can be a major issue. And if you're doing anything for like printing, reporting, where you're doing some sort of customizations on the object, you have to make sure you're setting these customizations on what's going to be printed or viewed and not on the secondary object. So if you're going to be printing the data store, then it's not an issue, but if you're printing actually the data window and that's your main object, then the customizations have to be applied to the appropriate place. So this is how the share data method actually looks. You'd send in the data window, you grab the syntax, store in a string, call the create function, call the share data, and then you would run your operations on the data store. So it's pretty straightforward and easy. So the last major option is a common ancestor, where we're creating an MVO that basically has the same function names as a data window or data store has. You simply have a function to register the data window or data store that you're doing the operations upon. And because you're doing it that way, your operations are actually being done on the registered objects directly. It's not like shared data where you're doing the operations on a copy of something, but you're doing it on the actual objects. So it's pretty straightforward. What ends up happening is each function you're creating is actually a very simple case statement, so it's pretty fast. You also have the runtime IDE checking of their spelling and fence typos, that sort of thing. Let's have some comparisons to the different options that we've talked about so far. So along the top, we have the different options, which is if then, using dynamic keyword, function overloading, creating the share data, and lastly is our common ancestor. So for things like runtime speed, You can see they're all pretty fast except dynamic, which we talked about being 25 times slower. Again, that's probably not an issue in most situations, but it is something to consider. The second one is really how well it works with large blocks of code. It's really maintainability and readability. And again, the dynamic, the shared data, and the common ancestor are actually all pretty good with that. The difficult ones are the if-then statements and function overloading. And that's just because you are duplicating a lot of code. If-then is probably the worst situation because if the extra if-then and else and ifs is located within your code. Having the IDE validate as you're typing to make sure that you're getting stuff in correctly, not waiting to runtime to have it fail is pretty important. The dynamic keyword fails miserably at that. Having all functions work, all your standard data window functions work is pretty important. The shared data has the biggest issue with that. Common ancestor that does a little bit as well, and we'll talk about some workarounds for that. Same thing with error information pretty much. It not being a copy, it's not really a huge deal, but in some situations that might be important. So again, if it's a reporting type of application or module that you're working on, the shared data is a little bit worse on that because of you're not quite sure which one's going to be presented to the user as a report or on screen. And if you have customizations that occur at runtime, that can be an issue. Having the ability to extend functionality, I think that's a pretty big bonus. Not strictly required, but it is a bonus. And the common ancestor, you can do that very easily. And I'll show you some functions that we've extended in our standard common ancestor for that. Refactoring usability, that's really a huge thing. So the common ancestor, you can very easily just sort of drop in replacement as a data window or data store if you're creating your NVOs to have some common processes. So that's a pretty nice feature. And then ease of maintainability. The shared data and common ancestor really make it very easy to maintain that sort of, really make it easy to maintain your code. So it has all the benefits of the IDE working. You're not having extraneous if-thens. You have code in just one place. So it's very, very powerful that way. So to work around the lack of error functions, you have really a couple ways to handle it. The one way, of course, is using a common ancestor. As long as your application is consistently using the same ancestors for data windows and data stores, and you have that function coded, it's pretty easy to do this. Another way of doing it is using a trigger event to figure out whether or not you are actually using a common ancestor. So if you are, then you can call the appropriate function, and if you're not, I guess just skip by it or come up with some other method, or maybe you have a couple of different types of ancestor objects that have those error functions. The last choice is use a class definition. Not supported in Power Server. Again, might be in Power Server 2021. It's also going to be kind of slow because I think you have to do some sort of recursive calls possibly to it, or some sort of hierarchy traversal in the class definition to sort of figure out what it is that you have. So that may work or may not work. So if you're going to use a trigger event to determine whether or not an ancestor is a specific type, what you would do in that particular case is you create an event that doesn't really do anything other than it's there. And the idea is if you trigger an event and the event exists, it's going to return a 1. If the event does not exist, it returns 0. So you do have to trigger it as using a string as the rather than calling it directly. So instead of calling it like ids.ds.event ueismyds with parentheses, you'd simply trigger it this way with the string as a string variable. It'll go through, it'll check it. If it's able to trigger it because it exists, it'll return 1, even if it doesn't have any code in it. If it doesn't exist, you don't do anything. But if it does, you know that the error event or error function does exist. Then you can use the dynamic keyword to go and grab that error information. So let's talk about extending functionality. You can very easily extend functionality for things that maybe you commonly use, but the data window and DataStore don't actually easily provide to you. So for instance, getting an existing filter that's on a data window, you have to use a modify statement for that, or I'm sorry, the describe statement for that. You can just create a standard function called get filter. There's a set filter, but not a get filter. Go figure. You can do the same thing for things like evaluate. That's a very powerful function that's available is within the data window object itself. So instead of doing a describe with evaluate, you can just call an evaluate and have some common code to figure all that stuff out for you. Same thing with like min, max, sum. So a lot of standard functions that I know that I use a lot that don't exist on a data window or data store. You can actually put on your data window ancestor, or yes, your data window ancestor object to provide easier functionality for that. So before actually we go to Q&A, just going to go back here to Power Builder. So this was the original object we talked about with the modified user and how it's basically sets your user code or username on a row when some data was changed. So let's go and see how that looks. This is the old way I did it with an if-then statement. So this is how it looks using the common ancestor object. So here's my pre-update, and you can see it's a much smaller amount of code. Why don't you do this? So it's much smaller amount of code. You don't have all those if-then statements. You can really read it in one block of code. It makes it easier to change stuff. Looks pretty much identical. I mean, look at it. It's, you know, just calling the direct set items on it. The difference is, you know, again, we're only registering it to the data window ancestor object, as opposed to, you know, either of these. We also don't have this Boolean statement here. The registration then is a little bit different too. So if I'm registering a data store, I'm creating this, but then I'm just registering it here as well. And then the same thing here. And notice the last thing I'm doing is calling the actual register. So I do have a third register function on here where I'm taking a data window ancestor. So in the event that I'm using a data window ancestor object that I'm registering this modified setting object on, I can work it for there as well. But this is the one that does the actual work of the registration process. So, and this is an example then of what my data window ancestor object actually looks like. And we can see a few functions here. Here's a get item, date, time, for instance. Again, just case statements. It's overloaded, so you have it with a buffer. This is a function that built to extend out this object, this ancestor object, to grab the current filter from data window or data store. So it does the describe. It does the describe on this object, which has been coded. And so this is where the describe looks. So again, the describe is pretty standard, just a case statement, just like anything else. But what we're doing is for the extended functions that we can then call the functions that they're built upon. So the describe function, which is coded already in here. So what's nice then is you can do that with other things as well. So here's an evaluate. So if you're doing a lot of evaluates, you know, again, you can do your describes. So you can also add additional functionality, such as the build a function here to over tilde extra quotes, so that everything tends to work, regardless of whether you're using single or double quotes within your expressions for your describes. So you can add functions like that, which are, again, pretty nice to have in a data window, data store centric object. So that's pretty much it for the presentation. Here's some links. And thank you very much.